Section 220.31 of the National Electrical Code, or NEC, is relevant when neither air conditioning nor heating is to be installed in a new structure. Section 220.31 applies when either air conditioning or heating is to be installed. The contractor's situation involves adding a pool heater to an existing service that already has air conditioning and heating. Therefore, the calculation should be performed in accordance with Section 220.31, since heating is already installed. The language in Section 220.31 clearly states when neither air conditioning nor heating is to be installed. Section 220.31 specifically states when air conditioning or heating is to be installed, which encompasses the contractor's situation. The NEC is intended to provide clear and unambiguous guidelines, and using Section 220.31 ensures consistency in calculations and safety. The contractor should perform the load calculation using Section 220.31, taking into account the existing air conditioning and heating loads, as well as the additional load from the pool heater. The calculation should determine the total load in the service and ensure that it does not exceed the service rating. Now let's break this down further to understand the underlying principles and how to apply these NEC sections correctly. The NEC, or National Electrical Code, is a comprehensive set of standards and guidelines designed to ensure the safe installation of electrical wiring and equipment. It's updated every 3 years, and it's crucial for electricians, contractors, and inspectors to stay current with the latest edition. Load calculations are a fundamental aspect of electrical design. They determine the total electrical demand that a building or system will place on the electrical service. Accurate load calculations are essential for selecting the appropriate size of service entrance conductors, overcurrent protection devices, and other electrical equipment. Overestimating the load can lead to unnecessary expenses and inefficiencies, while underestimating the load can result in overloaded circuits, voltage drops, and potentially hazardous conditions like overheating and fire. Section 220 of the NEC covers branch circuit, feeder, and service calculations. It provides the methods and guidelines for calculating the loads for various types of occupancies and equipment. Section 220 is divided into several parts, each addressing specific aspects of load calculations. The specific sections we're discussing, 220.31 and 220.31, deal with optional calculation methods for dwelling units. Dwelling units are defined as single-family homes, apartments, and other residential living spaces. These optional calculation methods are often used to simplify the load calculation process for dwelling units, while still ensuring a safe and adequate electrical system. Section 220.31 provides an optional calculation method for single-family dwellings, multifamily dwellings, and individual dwelling units in multifamily dwellings. This method allows for a reduced demand factor to be applied to the total connected load, which can result in a smaller service size compared to the standard calculation method. However, there are specific conditions and requirements that must be met to use this optional calculation method. These are detailed in subsections A and B. Section 220.31 states that this calculation is permitted only when neither air conditioning nor electric space heating is to be installed. This is a key condition. If either air conditioning or electric space heating is present, this subsection cannot be used. The rationale behind this restriction is that air conditioning and electric heating are significant loads that can substantially increase the overall electrical demand of a dwelling unit. Ignoring these loads in the calculation would result in an undersized service and potentially unsafe conditions. Section 220.31, on the other hand, applies where air conditioning or electric space heating is to be installed. In this case, the calculation must include the larger of the air conditioning load or the electric space heating load. This ensures that the service is adequately sized to handle the additional demand from these appliances. The NEC defines air conditioning load as the sum of the nameplate ratings of all air conditioning equipment connected to the electrical system. This includes central air conditioners, window units, and other cooling devices. Electric space heating load is defined as the sum of the nameplate ratings of all electric space heating equipment, such as baseboard heaters, electric furnaces, and heat pumps. When calculating the load according to 220.31, it is essential to determine which is larger, the air conditioning load or the electric space heating load, and use that value in a calculation. This is because these two types of loads are unlikely to operate simultaneously at their full capacity. For example, in a warm climate, the air conditioning system will be used more frequently than the electric heating system, and vice versa in a cold climate. Including only the larger of the two loads provides a more realistic estimate of the maximum electrical demand. Now let's consider the contractor's situation in the original question. The contractor is adding a pool heater to an existing service that already has air conditioning and heating. Since the dwelling already has air conditioning and heating, section 220.31 cannot be used. The correct section to apply is 220.31. This means that the load calculation must include the existing air conditioning and heating loads, as well as the additional load from the pool heater. The pool heater load should be calculated based on its nameplate rating, which indicates the amount of power it consumes. The total load on the service is then the sum of the air conditioning load, the heating load, the pool heater load, and any other loads in the dwelling unit, such as lighting, appliances, and general use receptacles. After calculating the total load, it is crucial to compare it to the service rating. The service rating is the maximum amount of power that the electrical service can safely deliver. It is determined by the size of the service entrance conductors and the rating of the main overcurrent protection device. If the total calculated load exceeds the service rating, the service must be upgraded to a larger size. This may involve replacing the service entrance conductors, the main overcurrent protection device, and potentially other electrical equipment. Upgrading the service can be a significant expense, but it is essential for ensuring the safety and reliability of the electrical system. It is also important to consider future loads when performing load calculations. If there are plans to add additional electrical equipment in the future, such as a hot tub, a workshop, or an electric vehicle charger, these loads should be included in the calculation to ensure that the service is adequately sized. In some cases, it may be more cost-effective to install a larger service initially rather than having to upgrade it later. Let's look at an example. Suppose a dwelling unit has an existing air conditioning load of 5,000 watts and an electric heating load of 3,000 watts. The contractor is adding a pool heater with a nameplate rating of 4,000 watts. According to section 220.31, a load calculation must include the larger of the air conditioning load or the electric heating load, which in this case is 5,000 watts. The total load on the service would then be the sum of the air conditioning load, the pool heater load, and any other loads in the dwelling unit. Let's assume that the other loads in the dwelling unit total 8,000 watts. The total load in the service would then be 5,000 watts, plus 4,000 watts, plus 8,000 watts, which equals 17,000 watts. If the service rating is 20,000 watts, then the service is adequately sized to handle the total load. However, if the service rating is only 15,000 watts, then the service must be upgraded. It's also worth noting that the NEC allows for demand factors to be applied to some loads, which can reduce the total calculated load. Demand factors are based on the assumption that not all loads will operate simultaneously at their full capacity. For example, the NEC allows for a demand factor of 75% to be applied to the total lighting load in a dwelling unit. This means that only 75% of the total lighting load is included in the load calculation. Demand factors can be a useful tool for reducing the total calculated load, but they must be applied carefully and in accordance with the NEC. In addition to section 220.31, there are other sections of the NEC that may be relevant to load calculations for dwelling units. Section 210 covers branch circuits, which are the circuits that supply power to individual outlets and appliances. Section 215 covers feeders, which are the circuits that supply power from the service entrance to the branch circuits. Section 230 covers service entrances, which are the conductors and equipment that connect the building to the utility power grid. These sections provide requirements for the sizing and installation of conductors, overcurrent protection devices, and other electrical equipment. It is important to consult these sections of the NEC when performing load calculations and designing electrical systems for dwelling units. Understanding the NEC and applying it correctly is essential for ensuring the safety and reliability of electrical systems. Load calculations are a critical part of this process, and it is important to follow the guidelines and requirements of the NEC to ensure that the service is adequately sized. Section 220.31 is only applicable when neither air conditioning nor electric space heating is to be installed. When either of these loads is present, Section 220.31 must be used. The contractor's situation in the original question falls under Section 220.31 as the dwelling already has air conditioning and heating. The load calculation must include these loads, as well as the additional load from the pool heater. The total load and the service must then be compared to the service rating to ensure that it is adequately sized. If the total load exceeds the service rating, the service must be upgraded. By following these guidelines and requirements, electricians and contractors can ensure the safety and reliability of electrical systems in dwelling units. Furthermore, let's clarify some potential misunderstandings. One common error is applying 220.31 when air conditioning or heating is present. Remember, the absence of both air conditioning and heating is a strict requirement for using 220.31. Another error is neglecting to include the pool heater load in the calculation. All loads must be accounted for to determine the total demand and the service. A third error is failing to compare the total calculated load to the service rating. The service rating is the upper limit of power the system can handle. Ignoring this step could lead to dangerous overloading. Accurate record keeping is essential throughout the load calculation process. Document all loads, demand factors, and calculations for future reference and for inspection purposes. This documentation demonstrates compliance with the NEC and provides a valuable resource for troubleshooting and maintenance. It is also good practice to consult with a qualified electrical engineer or inspector when performing load calculations, especially for complex or unusual situations. These professionals can provide expert guidance and ensure that the calculations are accurate and compliant with the NEC. Code compliance ensures safety and protects property. Non-compliant electrical systems can pose significant risks, including fire, electric shock, and equipment damage. By following the NEC and performing accurate load calculations, these risks can be minimized. In addition to the technical aspects of load calculations, it is also important to consider the ethical and professional responsibilities of electricians and contractors. Electrical work is a highly skilled profession that requires a commitment to safety and quality. Electricians and contractors have a responsibility to protect the public by ensuring that electrical systems are installed correctly and in accordance with the NEC. This responsibility extends to load calculations, which are a critical part of ensuring the safety and reliability of electrical systems. By adhering to the highest ethical and professional standards, electricians and contractors can build trust with their clients and contribute to a safer and more sustainable electrical infrastructure. Remember that local codes and regulations may also apply to electrical installations. These codes may be more stringent than the NEC in some cases, and it is important to be aware of them and comply with them. Local codes are typically enforced by local building departments or electrical inspection agencies. These agencies may require permits for electrical work and may conduct inspections to ensure compliance with the codes. It is important to obtain the necessary permits and schedule inspections before beginning any electrical work. In conclusion, understanding and applying Section 220.31 and 220.31 of the NEC correctly is crucial for accurate load calculations in dwelling units. These calculations ensure that the electrical service is adequately sized to handle the total electrical demand, preventing overloading and ensuring safety. Always remember that 220.31 is strictly for situations when neither air conditioning nor electric heating is installed, while 220.31 applies when either or both are present. The contractor's situation, involving the addition of a pool heater to a dwelling with existing air conditioning and heating, clearly falls under 220.31. Accurate calculations, careful documentation, and adherence to local codes are essential for safe and compliant electrical installations.